Sweet. So, acids and bases. Something popped up on the screen.
So how many moles is it in excess?
No, it's fine.
Okay.
It was 0,005 moles in excess.
How? 0.05. I got 0.015.
You have 0,02 moles of the other one. Mole ratio is 2 to 1. So you need half as much, which is 0,01. And you have 0,015. 0,015 minus 0,01 gives you 0,005.
So I divide this by its ratio.
When you just divide by that times that,
I divided by 2.
cool, can we carry on? Your calcium carbonate was in excess by 0,005 moles.
0.005 or just 0.5?
The memo made a mistake, it's 0,05. Yeah. Sweet. You guys with me? It's the last 30 minutes. Please give me a quick yay to say you're awake.
Yeah.
No, like a yay.
Yeah.
Okay. Anyway, okay. Acids and bases, right? So with acids and bases, we have quite a bit to cover. So if you guys turn to page 26. We're going to do a very short one. Give me a real yay when you get there.
Yay!
Much better. You guys there? Cool. So now, as you can see now on page 26, it just gives you quick scribbles of summary of acids and bases, which will cover basically the key things we need to know. So you know that we have two models of acids and bases, yes? Hello? Two models of acids and bases?
Yep.
Yeah. The Bronsted-Lowry and the Arrhenius model. Yeah, okay. The Bronsted-Lowry states that an acid is a proton donor and a base is a proton acceptor. Okay. And then your Arrhenius model says acids increase the concentration of H3O plus, your hydronium ion when it's in water, and then bases increase the concentration of OH minus when it's in water. Okay. You can see the big flaw there with the Arrhenius model is that it only works when you're looking at acids and bases in water. If I had a substance there, I'm like, hey, Mike, is this an acid or a base? And there was like no water, we're in the desert or the drought we're experiencing right now, you'd be like, I have no idea. That was a corny joke to try to wake you guys up.
Yeah.
Anyway. Cool. Sweet. So now we have that, right? So now the key thing that I want us to quickly go through is, so now I'm going to give us the basic acid and base reaction that we all know. Okay? So we have HCl plus NaOH giving us
Salt and water.
yeah, which salt? NaCl and water. Please, I know none of you guys here will make that mistake, but people do make the mistake of thinking acid and base. Acid and base gives you salt and water. And it's not all, salt is not just NaCl, right? NaCl is a type of salt, it's table salt. But so your ionic compounds are what form your salts, right? So like calcium carbonate is a salt as well. Okay, so don't just, when you get given other things, you say, well, NaCl plus H2O, and then think, yeah, I nailed acids and bases. Cool. So now, when we have this here, which of these two is our acid and which one is the base? What's it called?
Conjugate acid base.
No, what's this acid called?
Chloric acid.
But you know where I was going.
Yeah.
Yeah. What's this acid called?
Hydrochloric acid.
So hydrochloric acid, right? So this is now my acid A1, right? So now when my acid, by the Bronsted-Lowry model, donates its H, what does it become?
Water.
Salt.
Yeah, it becomes the NaCl. So then this donates an H, and then accepts the sort of Na, and then becomes my that base 1. Yes? And then my NaCl, which is now the base on this side, we'll call that B2, right? gives the sodium away, it doesn't matter, but then picks up the H from the HCl to form our conjugate acid. Yes? And this is called?
Acid base conjugate pair.
Yes, our conjugate acid base pair. Well done. Sweet. So now, that's what we have there. Now, before we move on, I want to just quickly double check if you guys understand the concept between a strong acid, weak acid versus a concentrated acid and a diluted acid. Who knows the difference? Yes.
Concentrated acid is just lots of acid per volume, whereas a strong acid is just, I'm not stronger than enough different acids, but it's
Okay.
not a part volume.
Okay, I'll give you 6 out of 10. So, a concentrated acid, right, is an acid that has a lot of moles per unit volume. It's got a high concentration, right? But a strong acid is an acid that will
Except
dissociate or ionize nearly completely in water, right? So, acids will dissociate nearly completely in water if they're very strong, and if they're very weak, they'll only dissociate partially in water. Yes? So then that's sort of, we can see that by our pH scale. So now, 7 being our sort of neutral point, so this is our pH scale. 7 is like our neutral point, it's like distilled water, like pure water, 7, right? 14 is quite basic, that's where you get now your strong bases and your strong acids are down here with like 1 and so on. So the pH says these acids here dissociate nearly completely, okay? And everything around here is just sort of just partially. 2 seconds. Guys, we can take this. Take on. Come again? I sent you a text saying we're back. No, it's still sending out. It still says live on my side. Yeah. The connection. Okay, cool. Even when you refresh. Okay, fantastic. Cheers. That was a real last interruption.
Ernest, why has my school done this?
Why hasn't your school done this? They're probably saving it for this year.
Yeah.
Yay.
Everyone else has covered acids and bases, right?
Yeah.
Okay. They say, don't feel bad. You did organic chemistry last year.
Yeah.
Probably everyone else as well. But some schools didn't do it last year, they did it this year. Okay. Can we carry on? Sweet. So now we know what our acid is by the Bronsted-Lowry model, the Arrhenius model. We know what an acid-base conjugate pair is, and we sort of get the whole thing of strong, weak versus concentrated and dilute acids and bases. Yes?
Yeah.
Okay, cool. So now the one other thing before we get to titrations we need to look at is our acid-base reactions. Okay? So there's the basic one, the main one. Acid plus base gives you a salt and water. Right? Not a salt as in like a beating, a salt as in an ionic compound over there. I'm trying to get you guys to wake up. It's fine. You guys will get there. The joke or the real stuff? I was saying acid and base reactions, right? The main one is an acid plus a base will give us salt and water. Okay? And then who can name one more? Okay, if we have a metal, like an active metal, right, plus an acid, what do we get? No. Salt and hydrogen. Yeah. If we have a metal oxide plus an acid, what do we get?
Salt and water.
Salt and water. Not 11 in water, salt in water. Okay. And then if we have a metal carbonate,
Carbon dioxide, salt, and water.
plus acid, we get a salt, we get water,
Carbon dioxide.
and carbon dioxide. If we have a metal hydroxide,
Water.
plus an acid, we get
Water.
a salt and water. Did I leave one out? Okay. Makes sense. Okay. Now, to talk through titrations, what is the point of a titration?
Mixing acid and base.
Yes?
Determine unknown concentration.
Yeah, to determine the unknown concentration of either an acid or a base, right? By performing a neutralization reaction. Yeah? Okay. So it's very important that for titrations, you guys know how to sort of formulate all your acid and base reactions. Because if they just told you, we have this and that, and then from a titration, what's the concentration? And you don't even know how your reaction is going to look, you're in a bit of trouble. Yeah? Yes. Yes. Can sweet. Can I erase this or does everyone have this?
No, wait.
Okay, quickly. Done. Okay, sweet. Okay, guys, keep it down there. Okay, sweet. So now, when they ask the question about is this salt solution acidic, basic, or neutral, who gets incredibly confused and thinks, I have got no idea how to figure that out.
Pardon?
When they ask you about salt solutions, they ask you, is the salt solution acidic, basic, or neutral? Who's got no idea how to do that?
Me, obviously.
Okay, so I'm talking about now hydrolysis of salt solutions. Yeah? No? No as in you don't do it, no as in you don't know how to do it. Okay, for those that do that, okay? So if I gave you, I'm going to give you the quickest way of doing it so that we can actually get to the exercise. If I said calcium carbonate, I don't like calcium carbonate. Let's simple one, NaCl, okay? NaCl, would an NaCl solution be neutral, acidic, or basic? How do I tell? Well, you're going to then do the hydrolysis of the salt and determine whether the acid and base pair that created that salt were together more acidic or more basic or neutral. So then, if I break this up, it's going to be Na plus and Cl minus, right? With that in water, think about water breaks up into OH minus and H plus. So I'm going to put the OH minus with the positive ion and the H plus with the negative ion, right? That gives me NaOH and HCl. Sodium hydroxide, hydrochloric acid, that's a strong base. This is a strong acid, which will give me a very neutral solution. So then if you've got a strong acid, weak base, that's an acidic solution. Strong base, weak acid, that's a basic solution. If they're both strong, then it's neutral. If they're both weak, then it's neutral. Yes?
Yeah.
And in type, yeah?
Are we expected to know whether they're strong or weak?
Yeah.
How do you
You have to learn this list of strong and weak acids and bases. Okay. Sweet. Yeah, so just touch through that and then we can actually do the titration one quickly now. Okay? Do you guys remember the titration equation?
No.
Okay. if you think back to concentration, N is equal to C times V. Remember that? Hello?
Yes.
Okay. Similar equation. If I say that N of my acid is equal to the C of my acid times the V of my acid, and I divide that whole one by the same equation for the base. The N of my base is equal to the C of my base times the V of my base. And you end up with Na over Nb is equal to CaVa over CbVb. Yes? Yep. And that's the equation you're going to use to get your titration. So the titrations, usually what they'll say is, we have 5 grams of a particular base, right? Added to 100 decimeters cubed. That's a lot of water. Like 2 decimeters cubed of water, and we use that to, let's say, neutralize a certain acidic solution. We don't know what the concentration is, but we've got 1 decimeter cubed of that solution. Then you say, well, as you're pouring it in, it's noted that 0.7 decimeters cubed of my basic solution neutralizes my acidic solution. And then once you've got that, you work out the number of moles that actually went in there. And once you've got these number of moles, you can work out the concentration of your unknown acid using this equation. Yes? Okay, let's do an example. Okay, so now if we look at page 28, give me a quick woo when you get there. Okay, you can tell the day's nearly done. The enthusiasm's coming back again. Okay, I'm gonna do number 2 and then you guys can do the rest. Yeah? Okay. Number 2, 22.5 grams of pure sodium hydroxide crystals are dissolved in water. So I've got NaOH, 2.5 grams are dissolved in water. The volume of the solution is 250 centimeters cubed. So this is my mass, my volume is 250 centimeters cubed. Of the solution, 25 centimeters cubed are used to neutralize 15 centimeters cubed of an H2SO4 solution according to the following equation. So we got sulfuric acid, right, of unknown concentration. So we have the volume of this, which is 15 centimeters cubed, okay? And of this, the volume used, I'm going to put that as V used, to neutralize, was 25 centimeters cubed. Okay. Then they gave us our equation, which is sodium hydroxide plus sulfuric acid gives us sodium sulfate plus water. Acid plus base gives us salt and water. Basic. Yes? Basic. I'm corny, you'll get used to it. Okay. Calculate the concentration of my sodium hydroxide solution. So I had that mass in that volume, then we can find the concentration. C is equal to N over V, but I'm given the mass, not the number of moles, so we can then change this to number of moles is M over capital M. So we can then say C is equal to small m divided by V times MR. Or you can go work out the moles first and then plug it in.
Wait, so which volume do you use? The volume that was used?
The volume of the original mixture. So you're going to use, that was poured into that, so that would be the certain concentration you're using. Because even the volume that was used has the exact same concentration. Right? So if I mix like a concentrate like Oros or something, and then I pour half of my drink in yours, it's not going to be half the concentration. It'll be the exact same concentration, just half the moles. Yeah? Okay. Then we've got our mass being 2.5 grams. Our volume is 250 centimeters cubed. What is this in dm cubed? Divide by 1,000. It's going to be 0.25. And my relative molecular mass of sodium hydroxide is? Hello?
It's 23 plus 16 plus 1.
23 plus?
16 plus 1.
Which is?
40.
40. Okay. Times 40. Can I get an answer for that? 4 comma
0.25.
0.25. Okay. So this is 0.25 moles per decimeter cubed or molar. Yes? Okay. And then 2.2 says the concentration of my H2SO4 solution. So I can then use my titration equation. Right? Na over Nb is equal to Ca, Va, Cb, Vb. Right? Do I have to use these mole values that I calculate here for that? Why not?
Are they?
The mole values I calculate here, do I have to use them for that equation there?
No.
Why not?
Because it's only one of, it's only for NaOH that you worked out the moles.
Okay? Do I have to go work out the moles of my sulfuric acid?
Yes.
Remember, they gave you this reaction for a reason. 2, 1, 1, 1. Balanced chemical equation. Where it's missing two waters.
I think you also missed out the 2 Na2.
Na?
Na2, so.
Thank you. Okay. So I've got this mole ratio already. And Na over Nb is simply just a ratio of the number of moles of each of them. I don't need the actual values. I can plug in these values in there. It makes it easier. Yes? So if you still got this, if you got this question wrong, you can still get this right because they gave you the mole ratio in the balanced chemical equation. Yes?
Yes.
Cool. Nearly done, don't worry. Okay, now to get the concentration of my sodium, my sulfuric acid, I apply that equation over there, which is going to be Na over Nb times Ca, Va, Cb, Vb. Number of moles of my acid is 1. Divide number of moles of my base, which is 2, which is concentration of my acid is what I'm trying to find, right? Ca times the volume of my acid is 15 centimeters cubed, which is 0.015 dm cubed. Concentration of my base, we worked out there 0.025. 0.25. And then the volume of my base is the one that we used here. Yes? Okay, that's 0.025 as well. Why is it this? Because this works for the reaction. So this is the volume that I used initially to make the concentration. But only this much managed to neutralize my acid. So for the reaction, this is how much reacted. Therefore that's the value I'll use in here for my reaction. Does that make sense? Fantastic. And then if you solve for your concentration of your acid in that example there, you'll find that the concentration of your acid will be 0.21 moles per decimeter cubed. Okay. I want you guys to take 5 minutes to do number 1 on page 28. Do you guys have any questions, by the way? None. Okay. You guys okay? As it is. Number 1 on page 28.
Because I think you're good there.
Which I understand.
questions?
Yeah, I'm trying.
That's what I'm.
What's the time? I don't know if
Before you guys leave, can I just dismiss everyone? Guys, can I grab your attention quickly? Hello? Yeah, okay, cool. Just quick silence. Thank you guys so much for coming. Like I said, I will do the redox. I'll record a redox one today, and then I'll post it up by tonight. And then there was a special request for the Vespa. And I'll do the Vespa. I'll post the Vespa one up by Monday. Okay. And then that's what I'm going to give you guys the link now. Okay. So now what I'm going to do, as soon as I'm done with the whole recording, I'll give you guys the link and you guys sort of, the ones you can come and catch the redox one, maybe just revise some of the other stuff there. Thank you guys for coming so much. Thank you for being our pioneers for our first broadcast. Shout out to the guys in Cape Town. Thank you for being there and watching. I feel like I'm on TV now. But yeah, if you guys have any questions at all, please, 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 I will be here for the next 30 minutes. Please, if you have anything to ask me, stay, ask me. If you want to leave, thank you so much for coming. For those that I have met for the first time, I hope to see you guys again. We are going to have many more of these throughout the year to cover everything else. As soon as schools get back after the break, we're going to have a maths one. So just be on the lookout for the emails, they'll come to you. And yeah, hope to see you guys soon. And all the best for those that have prelims. Okay, cool. Thank you so much, guys. Yeah, we did it! Okay, let's go there now.